Hi everyone, so today we're going to look at bond energies and what's happening to the actual bonds during a chemical reaction, the energy involved in them. And this is starting on page 6 in your booklet. So if you remember in our last video we had this about what was needed for a reaction to happen. So we said the two things that were needed was the bonds had to be broken between the reactant molecules and then the new bonds had to form. And we said that bond breaking was endothermic because it needed energy to do that, and bond making was exothermic. The energy was released whenever these bonds were made. Now each type of bond has its own amount of energy that's needed, and this picture is on page 6 of your book, and it shows you that the amount of energy that's needed, this is for example between a chlorine molecule, between the two atoms of chlorine and a chlorine molecule, it takes 242 kilojoules per mole of energy to break the bond, but the same amount of energy is released when that bond forms. Okay, and we're going to look at some examples on how we use that bond energy information to work out our overall energy change for the reaction. Now, an easy way to do this is to use, now in school we would use our actual Molly mods, but we're not in school, so I had to improvise with some jelly tots and some cocktail sticks. So here is our CH4 molecule, and here are O2 molecules. So the balanced equation tells us how many of each we need. So we start off, the first thing we need to do is we need to break these bonds. And remember, it takes energy to break these bonds. So you can picture, you'll be able to do this better with two hands. So break the bonds between the molecules, atoms and the molecules of the reactants. So there we go, the individual atoms. And then the second thing that happens is that the new bonds form, okay? So right here is like a Blue Peter style. So here's ones I prepared earlier. So we've got new bonds formed between the carbon dioxide and the water molecules, and you can confirm that the same number of each type of atom was used, so the equation was balanced. We still had 1 carbon, 4 oxygens and 4 hydrogen, so you can say the equation was balanced. If you were doing this yourself at home, you'd be able to take apart the reactants and then join them together to make the products. It was just for this video I had already prepared. So if we then look at that in terms of the energy involved in each of these, okay, so if you don't want to go and buy jelly tots and make them, you can draw out the molecules the way I have here. This is on page 7 of your booklet. It gives you the table showing you what the bond energy is for each of these types of bonds, and in an exam question you'll be given the bond energies. You won't be expected to remember those. So we've got the bonds here. We've got the methane molecule, the oxygen molecules, carbon dioxide and the water. If we then look at it in terms of our bonds, so our bond breaking, we've got 4 times carbon hydrogen bonds and 2 times oxygen bonds. And our bond making, we've got 2 carbon oxygen bonds and carbon dioxide double bonds and 4 oxygen hydrogen bonds in the water. So then using the data from the table at the top of the page, we can work out the values, put values onto this for the values that's needed for the bond breaking and the bond making, okay? And remember then, to work it out overall, our overall energy change is bond breaking minus the bond making. And we put those numbers together, we can get this sum, and we should get a minus 806. Now, what that means in terms of our overall energy change, because it's a minus number, remember in our last video we said that if it was a minus number that it was an exothermic reaction, that there was energy given out. So there's 806 kilojoules per mole of energy given out in this reaction, okay? So on page 7, you can copy that one into the first example, and then there's 2 other examples for you to try. So let's see how you get on with those, and then you can ask me any questions on Google Classroom or send me an email if you have any questions. Thanks.